Hi friends, welcome back. Today we're talking about systems of equations in special situations. So grab your notes, draw out these graphs, and we're going to talk about what happens when we have these situations. First things first, we're going to graph these two lines, but in order for us to graph that, we first have to put them into slope-intercept form, meaning y equals mx plus b form, y equals mx plus b. So what I want to do is I'm going to minus 5x from both sides. So all I've done is rewritten the top one right here. And what I have now is negative y equals negative 5 minus 5x. We can't combine those. Those aren't like terms. So what we want to do is put them in the right order, though. So we're going to actually put minus or negative 5x minus 5 like this. Now what I need to do is divide everything by a negative 1 so I get that y by itself. All right. Negative divided by negative is a positive. Negative divided by negative is a positive. And negative divided by negative is a positive. Okay, that's our first line that we're going to be graphing. Our second one is going to be this. Let me rewrite this guy as well. All right, 3x minus 6y equals 24. Again, we want to get the chunk with the y by itself, so we're going to minus 3x from both sides. What I have now is negative 6y equals, and again, 24 minus 3x, can't combine those. Those aren't like terms. So we're going to put them in order. Negative 3x plus 24 as opposed to 24 minus 3x. Divide everything by negative 6, all of our little chunks here, and we get y equals, because those go away, negative divided by negative is a positive. 3 over 6 reduces down to 1/2 x. Positive divided by a negative is a negative. And 24 divided by 6 is going to be 4. All right, so these are the two lines that we need to graph. I'm going to go ahead and graph this guy first here. We're going to start at positive 5. So we go 1, 2, 3, 4, 5 right here. Now our slope is 5 over 1, but remember, you can always write slopes two different ways. In this case, 5 over 1 is the same as negative 5 over negative 1 because negative divided by negative would be a positive. And that's helpful because you'll see if I do positive 5, I'm going to be way off the graph. So it's good to be able to rewrite these. So we're going to go down 5 and in the negative direction 1. Down 5, 1, 2, 3, 4, 5, and in the negative direction 1. Excellent job. Then for our, let me grab my straight edge here. And when you're doing this, you absolutely want a straight edge because otherwise you'll get you run the risk of getting the wrong answer. All right, so there's my first line that I have graphed here. Now, the second line that I'm going to graph here, we're going to start at negative 4. And then our rise over our run is 1 over 2. So I can rise up 1 and run in the positive direction 2. Or I can go down 1 and in the negative direction 2. Down 1, negative 2. Either way, those, and you're going to want to do your slope all the way across until your lines cross. You see mine already did, but it's a helpful thing to do that. Okay, so in this case, what we have is a solution to our equation. Now, you may have heard independent, dependent, inconsistent, consistent. We're going to talk about that when we have all three of these guys done. But for right now, you should know that this is consistent and independent. Consistent and independent. We'll come back to good notes on how that works. All right, let's graph this next one together. You'll see that for the first one, we have 2x minus 2y equals 14. And then our other one is x minus y equals 2. Well, straight away, I look at this first one and I see, you know what? Everything there is divisible by 2. Let's go ahead and just divide everything by 2. All right. When we do that, we get x minus y equals 7. Okay, well, now we can go ahead and solve for y. So if I minus x from both sides, I get negative y equals negative x plus 7. Now, I want to divide all of these by a negative 1, and all that really does is just change your signs. So you can just change the signs. Positive, positive, negative. That's all dividing or multiplying by negative 1 does. So there's that guy that we get to graph. Now over here, same idea. We're going to minus x. Negative y equals negative x plus 2, and divide everything by negative 1, which again just changes the signs. Y equals positive x, negative 2. All right, we go to graph these two guys. Negative 7, that one's going to be all the way down here. 5, 6, 5, Let me see, 1, 2, 3, 4, 5, 6, 7. That's all the way down here. That one's a little low. Sorry about that. And so we're going to go, our slope is up 1 over 1, right? So we go in this direction, up 1 over 1. Just like that. Now, and then of course we use our straight edge, which I always misplace as I'm working. I don't know why. Okay, so there's our straight edge. Kablam. If you don't have a ruler, you can just fold a piece of paper in half. All right, this guy right here, -2. We start right here. Same slope. We rise up 1 over 1, up 1 over 1, up 1 over 1. You'll notice with these same slopes, these lines are parallel. Parallel lines have the exact same slope, which means their lines are never going to cross. This means we have no solution here. No solution. Now that's different from our previous one where we had a solution right here. That was over -2 down -5. -2, -5. That was our solution. When we have no solution here, it is just inconsistent. That's it. No solution, inconsistent. Okay, now we've got another one here. We've got these guys. So for this one right here, we can go ahead and graph that pretty easily. We're going to say -4, so 1, 2, 3, 4. And then our slope is 2, and we can always turn it into a fraction by putting it over 1. Rise up 2, and in the positive direction 1. Up 2, 1. Up 2, 1. Good. Let's use our straight edge here. Make sure we got that. We can also go down 2 and in the negative direction 1 to give us that other slope. So that it goes both ways. All right, there's our straight edge. Good. Now this next one right here, we're going to go ahead. I'm going to rewrite that. We got to put it into slope-intercept form in order for us to graph that. So -6x from both sides. That leaves us with -3y equals -6x plus 12. Divide everything by -3. Y equals negative divided by negative is a positive. 2x and positive divided by a negative is a negative. So we get -4. All right, well, you see if I go to graph this guy, it is the exact same line as that first one that I graphed, right? So if I go to graph it, it's going to be right on top of the other line. That means that there are an infinite number of solutions because those lines cross at an infinite number of places. So this is infinite solutions, infinite number of solutions, many solutions, infinite many solutions, anything like that, infinite solutions. Now, when we have infinite solutions, this one is consistent, but it is dependent, as opposed to our one solution is consistent and independent. So how can you remember that? Here's a great little flow chart to put into your notes. If you have a solution, is there a solution? If that is yes, there is at least one, and then no. If there's at least one solution, yes, then it is a consistent graph. The solution is consistent. If there's only one solution, it's independent. It does not depend on the other graph in order to find that solution. If there is at least one graph or one solution, it is consistent. But if there's more than one solution, meaning if there are an infinite number of solutions, then it is dependent. If there is no solution, it's inconsistent. We don't care about the independent-dependent thing. Hopefully this helps.